I will talk about viewpoints and visualization from ArchiMate perspective. As we know, establishing and maintaining a coherent enterprise architecture is clearly a complex task because it involves many different people with differing and distinguished backgrounds using various notations. To integrate the diverse architectural descriptions, we advocate an approach in which architects and other stakeholders can define their own views of the enterprise architecture. In this approach, views are specified by viewpoints. Viewpoints define abstraction on the set of models representing the enterprise architecture, each aimed at a particular type of stakeholders and addressing the a particular set of concerns. Viewpoints can be used both in to view certain aspects in isolation and for relating two or more different aspects. Architecture viewpoints. The use of multiple viewpoints is motivated by the observation that it allows to address separately the concerns of the various stakeholders of the architecture. End users, such as end users, developers, system engineers, project managers, etc. And to handle separately the functionality and non-functional requirements of the system. Here I will be talking about a list of some examples of stakeholders and their concerns which could typically serve as the basis for the selection of viewpoints. First group is the upper level management. It's about how can we ensure our policies are followed in the development and operations of processes and systems. Second group are middle level managers, people who currently, the current situation with the concern is the current situation with regards of the business process itself. Another group is end users, where their concern is about what is the potential impact of a new system on the activities of a particular prospective user. Another group, architects, their concern is what are the consequences for the maintainability of a system with respect to corrective, preventative, and adaptive maintenance. Operational managers are concerned about the question where what new technologies do we need to prepare for? Is there a need to adopt maintenance processes? What is the impact of changes to existing applications? The view content refers to the view is a selection or derivation from a symbolic model of the architecture and is expressed in terms of the same modeling concepts. The presentation or a notation of this view refers to as visualization. And is expressed in terms of the same modeling concepts. The presentation or notation of this model or this view, referred to as a visualization. It can take many forms, from standard diagrams to tables, cartoons, or even dynamic visualizations like movies and so on. In this perspective, we have three main issues. One is the view, the other one is viewpoint, and the other one is visualization. View refers to views expressed by TOGAF framework. Viewpoints are the viewpoints equivalent of the views, or the expression of the views of TOGAF in ArchiMate tool or ArchiMate language. And the visualization is actually the artifact that is a product of visualizing the viewpoints by ArchiMate. An architect is confronted usually with many different types of stakeholders and concerns. To help the architect in selecting the right viewpoints for the task at hand, we introduce a framework for the definition of classification of viewpoints and views. The framework is based on two-dimensional purpose and content. The following three types of architecture support definition and purpose dimensions of architecture views. First item is the designing. Design viewpoints support architects and designers in the design process, from initial sketches to detailed designs. Typically, design viewpoints consists of diagrams like those we do in UML language. Deciding supports views that assist managers in the process of decision making by offering an insight into cross-domain architectural relations, typically through projections and intersections of underlying models. And informing, these viewpoints help to inform a stakeholder about the enterprise architecture in order to achieve understanding, obtaining commitment, and convincing the adversaries. Typical example of that is the illustration, animations, cartoons, flyers, and things like that. The goal of this classification is to assist the architects and others to find suitable viewpoints given their task at hand. For example, the purpose that a view must serve and the content it should display. For characterizing the content of a view, we define the following abstraction levels. We define the details, coherence, and overviews. In details, the views of the detail level typically considered one layer and one aspect from the framework that was introduced prior to this. Typical stakeholders are software engineers responsible for the design and implementation of the software, or a process owner responsible for effective and efficient process executions. Coherence, at the coherence abstraction level, multiple layers or multiple aspects are spanning, extending the view to more than one layer or aspect, enabling the stakeholder to focus on architectural relations like process use system, multiple layer or application use object, and so on. The overview abstraction level addresses both multiple layers and multiple aspects. This is the table that explains what we just talked about. The purpose of those abstraction levels and the example in which we can use to make the abstraction. Now we'll be talking about some basic design viewpoints offered by ArchiMate to illustrate the views expressed in TOGAF framework. Based on common architectural practices or experience with the use of ArchiMate, models in practical cases and on the diagrams used in other languages like UML, we have selected the most useful combinations in the form of standard set of basic viewpoints to be used with the ArchiMate concepts. Some of those viewpoints have a scope that is limited to a single layer. Things such as the business function and business process viewpoints that shows the two main perspectives on the business behavior. The organization viewpoint, which depicts the structure of the enterprise in terms of its departments and roles and etc. The information structure viewpoint describes the information and data used in the enterprise. The application structure, behavior, and cooperation views containing the application and components and their mutual relations. And the infrastructure viewpoint that shows the infrastructure and platforms underlying the enterprise information systems to, in terms of networks, devices, and system softwares, firmwares, and so on. And there are and the other viewpoints that links multiple layers and or multiple aspects are ones such as actor cooperation and product viewpoints that relate the enterprise to its environment. The application usage viewpoint relates the application to their use in or, for example, business processes. And the deployment viewpoint show how applications are mapped into the underlying infrastructure. Now I'll go through some of these viewpoints. Introductory viewpoint is it's a form is a subset of the full ArchiMate language using a simplified notation. It is typically used at the start of the design trajectory when not everything needed to be detailed. So this is a very, very high level view of the system. It's to explain the essence of an architecture model to non-architects who require simpler notations. We use simplified notations here in this diagram, and for relations. All relation aspects, triggering and realizations are denoted by simple lines. Realization is called realization. It has an arrow in the direction of the realization service or realized service. Triggering is also represented by an arrow. The concepts are denoted with slightly thicker lines and rendered corners which give a less formal impression on that. The other one is organization viewpoint, next step. The organization viewpoint shows the structure of an internal organization of the enterprise, departments or other organizational entities within the enterprise. It can be represented in the form of a nested block diagrams, but also in more traditional ways like the other organizations or organisms. An organization view is typically used to identify authority, competencies, and responsibilities within the organization. Actor cooperation viewpoint focuses on the relations of actors with each other and their environment. A common example of this is what is sometimes called context diagram, which puts an organization into its environment, consisting of external parties such as customers, suppliers, and other business entities. Here we can see in this example actors such as customers, insurers, and the insurance, the insurance company itself, the enterprise itself, as different entities, and it depicts their relationship in relation to the functionality of the system. Business function point of views show the main business function of an organization and their relationships in terms of the flows of information, value, or goods between them. Business functions are used to represent what is most stable about a company in terms of the primary activities it is performing, regardless of organizational changes or technological development, of course. Here we can see the information flow associated with the handling of insurance claims. Claims are submitted to the maintaining customer relationship or customer relations business function, processed by claim handling and paid by the financial handling. The business function viewpoint provides high-level insight into the general operation of the company and can be used to identify necessary competencies or the structure or to structure an organization according to its main activities. Next diagram is the product viewpoint. This is one of the most important diagrams in every enterprise, because whatever enterprise we will be designing will have some sort of or some type of products or services. We'll definitely talk about the services later as well. The product viewpoint depicts the value this product offers to the customers or other external parties involved, and shows the composition of one or more products in terms of the business or application services, and the associate contracts or contract or other agreements that it relates to this product. A typical insurance product of our example, which is ArchiSurance, is illustrated here. The value to the customer of an insurance is typically the added security it provides. The service mentioned here are realized by various business processes. The product view is typically used in designing a product by composing existing services or by identifying which new services have to be created or for this product given the value a customer expects from it. Service realization viewpoint. In this viewpoint, business services are realized by business processes. So you want to present your customers with a service. Behind this service that you present to your customer, you need to have a business process. The service realization viewpoint is used to show how one or more business services are realized by the underlying process. It forms the bridge between the product viewpoint and the business process viewpoint. It provides a view from the outside of one or more business processes. Business process cooperation view is used to show the relations of one or more business processes with each other and or their surrounding environment. It can be used both to create a high-level design of business processes within their context and to provide an operational management or operational manager responsible for one or more such processes with insight into their dependencies. Some important aspects of the coordination are causal relation between the main business process of the enterprise, the mapping of a business process into business functionality, realization of a service by business processes, the use of shared data, and finally the execution of business process by the same rules or actors. Business process viewpoint is used to show the high-level structure and composition of one or more business processes. Next to the processes themselves, this viewpoint contains other directly related concepts such as the service a business process offers to the outside world, showing how a process contributes to the realization of a company's products. The assignment of business process to roles, which gives insight into the responsibilities of the associated actors and the information used by the business process itself. Information structure viewpoint. The information structure viewpoint is basically identical to the traditional information models created in the development of almost any information systems. It shows the structure of the information used in the enterprise or in a specific business process or application in terms of data types or class structure, depending on object-oriented or non-object-oriented systems. Application cooperation viewpoint shows the relationship of a number of applications or components. It describes the dependencies in terms of the information flows between them, or the services they offer and use. This viewpoint is typically used to create an overview of the application landscape of an organization itself. Application usage viewpoint describes how applications are used to support one or more business processes, and how they are used by other applications as well. It can be used in designing an application by identifying the services needed by business processes and other applications, or in designing business processes by describing the services that are available for those processes. Application behavior viewpoint describes the internal behavior of an application or a component. As you know, we have APIs and processes for every application. The process is an internal behavior of an application, and API is the external view of that application. Here, what we concern about is the internal view of the application. An example of such thing is as it realizes one or more application services. This viewpoint is useful in designing the main behavior of application or components, or in identifying functional overlap between different applications. You can see the internal behavior of an application, and this way we can avoid duplicated or duplication of behavior between different applications. So this is a much more detailed design of what an enterprise architecture will prescribe. However, it is really important to have such designs in order to avoid duplicated behavior between applications, and also provide more direction, a better direction into the implementation of those applications. Application structure viewpoint shows the structure of one or more applications or components. This viewpoint is useful in designing or understanding the main structure of applications or components and the associated data. One example is to create a first step work breakdown structure for building a system, or in identifying legacy parts suitable for a migration project. Infrastructure viewpoints comprises the hardware and software infrastructure upon which the application layer depends. It contains physical devices and networks, and supporting system software such as operating system, databases, and middleware, as well as firmware. Infrastructure usage viewpoints show how applications are supported by the system software and hardware infrastructure. Infrastructure service delivered by the devices, system software and networks are provided to the application. This viewpoint plays an important role in the analysis of performance and scalability, since it relates the physical infrastructure to the logical world of applications. Implementation and deployment viewpoints is the final viewpoint that I'll be discussing. This viewpoint shows how one or more applications are deployed on the infrastructure. This comprises the mapping of logical applications and components into physical artifacts, like for instance enterprise Java beans if you use Java technology, and the mapping of information used by these applications and components into underlying storage infrastructure, such as database tables or file system. And in summary, in this section, we've been advocating a viewpoint-oriented approach to enterprise architecture modeling, which is what ArchiMate is providing. In short, I'd say ArchiMate viewpoints are somehow mapped to TOGAF views, and although ArchiMate does not have viewpoints corresponding to TOGAF views in one-to-one relationship, but nonetheless, for most of the views in views discussed by TOGAF framework, ArchiMate has almost one viewpoint that illustrates the view discussed by TOGAF. Architects and other stakeholders can define their own views of the architecture using viewpoints we mentioned here. In this approach, views are specified by viewpoints. As I said, views discussed by TOGAF is expressed or specified by viewpoints in ArchiMate. But we should take care not to confuse the viewpoints and views in TOGAF and ArchiMate. TOGAF and ArchiMate are not two equivalent things. TOGAF is the framework and ArchiMate is the language that implements those views.